the bizarre anti-gravity waterfall, defying gravity with ferrofluid. What if I told you there's a liquid that climbs upward against gravity, forming spiky alien shapes when exposed to a magnet? No CGI, no tricks, just one of the most visually stunning physics demonstrations you'll ever see. Today we're playing with ferrofluid, the liquid that laughs in the face of gravity and creates shapes you'd expect to see in a sci-fi movie. This isn't just cool to watch, it's revolutionizing medicine, engineering, and even space technology. Let's dive into the weird world of magnetic liquids. Introduction to the science. Ferrofluid is no ordinary liquid. It's a suspension of microscopic magnetic nanoparticles in oil, each about 10 nanometers across. That's 10,000 times smaller than a human hair. Normally, these particles move randomly like any fluid, but bring a magnet nearby and something extraordinary happens. The particles align with a magnetic field, creating spikes that seem to defy physics. This behavior comes from the balance between two competing forces: magnetic attraction, trying to pull the fluid toward the magnet, and surface tension, trying to keep the fluid together. The result? Those iconic spikes where the magnetic force exactly balances the surface tension. Step-by-step experiment. Let's create our own magnetic masterpiece. 1 materials needed: ferrofluid, available online, strong neodymium magnet, clear petri dish or glass container, gloves, stains, and vegetable oil to dilute if needed. 2. Setup. Place a small puddle of ferrofluid in the dish about the size of a quarter 3. The magic moment. Slowly bring the magnet underneath the dishwatch as spikes instantly erupt like a metallic cactus. L4. Advanced demo. Try moving the magnet in circles. The spikes will dance and reform in real time. Pro tip: shine a bright light at a shallow angle to make the spikes cast dramatic shadows. The physics behind it. Here's why ferrofluid behaves so strangely. Insane. Magnetic nanoparticles. Each tiny particle becomes a mini magnet when exposed to a magnetic field. 2. Competing forces. Surface tension tries to minimize surface area while magnetic forces try to maximize it. 3. Spike formation. The spikes align with magnetic field lines, with each peak representing a perfect balance point. 4. Minimizing energy. The fluid arranges itself in the lowest energy configuration possible. This is a visible example of the normal field instability phenomenon, where a fluid develops patterns to minimize the total energy of the system. The exact same physics shapes sand dunes and cloud formations. Surprising results and applications. The wildest things happen when you use multiple magnets. The fluid forms bridges between them. Rotate the magnet quickly. Create swirling vortex patterns, place a magnet above. The fluid literally climbs upward against gravity. But this isn't just a cool demo. Ferrofluids are used in hard drives, seals that keep dust out while allowing the disk to spin, medicine, targeted drug delivery and cancer treatment, spacecraft, liquid seals in zero-gravity environments, arcade, dynamic sculptures that change with magnetic fields. Final conclusion and takeaway. What looks like a liquid from another planet is actually a perfect demonstration of how microscopic physics creates visible, tangible phenomena. Ferrofluid shows us that the boundary between solid and liquid isn't as clear as we think, and that magnetism can create order out of chaos. The next time you use a hard drive or hear about targeted cancer treatments, remember, it all started with a bizarre black liquid that couldn't sit still around magnets. Try this experiment yourself, safely. It stains. And let us know in the comments what other magnetic mysteries we should explore. Don't forget to subscribe for more experiments that look like magic, but are pure science.